So finally checking delta satisfiability of reals with integrals, and the talk is by Bishnu. Please.
Thank you. Hi everyone, I'm Bishnu. Today I'm going to talk about checking delta satisfiability of reals with integral. This is joint work with Cody, Rohit and Prasad and Mahesh. I would like to, before starting my talk, I would like to shout out to our first author, Cody. He is listening to us remotely. He could not come here, but despite being too late in US, he is listening to us. And our goal in this project is to extend delta decision procedure to reason about formula that includes integrals. So why it matters, like why we need integrals? So many verification and synthesis tasks can be reduced naturally to that involves integrals. So for example, if we consider the problem of verifying fairness of hiring algorithm shown in the right, where ethnicity greater than 10 means like a minority group. So to verify fairness, we have to check the probability of being hired given the minority status over the probability of hiring given non-minority status should be bounded by 1 minus epsilon. So this kind of probability, which involves Gaussian, will boil down to the formulas which have integrals. And to check this kind of formulas, there is no existing tool to solve it. So that motivates us to build a new tool. So we want to do this by extending the delta decision procedure. So now let me jump into what is delta decision procedure. So it's a key idea introduced by Gio et al. In 2012. Basically, the idea here is it provides the framework that approximately decide the formula over a real number with a small tolerance are satisfiable, delta satisfiable or not. So if we have the formula phi which is over real, if we feed to the delta decision procedure, output will be onsat, which means formula is unsatisfiable, or it will be delta sat. Basically delta sat means a delta weakened version of formula is satisfiable. So mathematically, like it is done that way. I have put original formula and the delta weakened version. So interestingly, formula can be onsat and delta sat at the same time. This is by design. That basically means the relaxed version, little relaxed version is delta satisfiable, but the exact one is onsat. So and this framework support any computable real function such as sine, cos, log or exponential. So this gives a way to solve integrals in a promising way. Now after talking about delta decision procedure, let me talk about our contribution. So our contribution are on threefold. First, we created the logic alint which support nested integral with variable bound. And after that, we proved disability of delta satisfiability for this logic. And finally, we implemented the tool called dReal, which basically support integral reasoning and can solve the problem I showed at the beginning. So now let me formalize the problem. So basically, what we want to do is we want to check the formula phi in the quantifier free first order logic over the real is delta satisfiable or not. What does it mean? Like what is new in term of terms? If you see, like that's highlighted term, the integral is the new one, new addition to the logic, and it has the variable inside integrands and the variable bound. It support variable bound also. So essentially we are asking, can we decide delta satisfiability when the formula involves integral? In order to solve this, we combine SAT solver with the theory solver. This combination is what leads us to our new tool in dReal. So for doing that, we have to, before diving deep what we made changes in the existing dReal, we need to learn about interval constraint propagation. So the core of delta decision procedure relies on interval constraint propagation. So basically, it sorts for the delta width box that satisfy all conditions. For doing it, it uses two operations. One is branching, basically it's naive way of splitting the boxes, and another is pruning. The pruning basically means we shrinks the size, the interval of box using the function property. The next immediate challenge is how we can prune efficiently when the integrals are involved. So for basically the dReal tool, which is the foundation for our work, uses SC4 revised algorithm to prune. So basically it has two parts. One is forward evaluation, which means computing the sound interval enclosures, and second is backward evaluation, computing the smallest smallest input interval which output intersect with the output interval. So we extend forward evaluation for supporting integral using ARB, integral enclosure using ARB. Later after this I will talk about ARB, but ARB basically is the library that support integration. So and we made change and we came up with the new technique for backward evaluation. Basically technique is we estimate how much each input variable contributes to the output, and we repeatedly shrink the interval using binary search. So now, we use ARB for integration. So it's a library which represent values as a ball. So ball basically means there will be midpoint, and there M is the midpoint, and the R is the error radius, and this provide rigorous numerical enclosure, and it provide integration procedure over arbitrary complex ball functions. So it uses algorithm that quickly converts on piecewise homomorphic function, and in our case we use like conservative estimation in our tool, so we can know our answer are safe. And basically we also convert between balls and interval. So basically we do that. I will talk about that in the next slide. This is overall architecture of our tool. So we use like a dReal uses something called IBEX. IBEX is an open source library for constraint solving of real. So it uses interval, but ARB use ball. So we do interchange between ball and interval in our tool, and basically we added the parser to support the logic, and in forward propagation it invokes ARB for computing integral enclosure, and in backward propagation it implements a binary search routine to do backward propagation. So that's overall architecture of our tool, and our tool is available on GitHub, and please download and use it for the problem which involves integrals. And now let me talk about the overall evaluation of our tool. So for evaluating tool, we created the suite of benchmark which consists of 41 benchmark, and it involves privacy problems, fairness problem, and the synthesis problem. So and our tool can handle a universal and existential quantifier, and we are often faster than Mathematica, which is industrial tool for doing this kind of thing. We only lose in triple integral case. Beside that, we almost always perform very good. If you see the speed factor, we almost always do reasonably well compared to Mathematica, and it is open source. And our result, despite being like a approximate decision procedure, our results are identical to exact satisfiability. And we have also a broader scope. Basically, most of the example we coded with the quantified alternation, Mathematica wasn't able to solve it, so our tool provides the broader scope. So now the next question clicks in the mind is how scalable is our tool? So because we can perform faster than Mathematica, and it is scalable? So for testing that, we created suite of example where we have the sum of nested integrals. So we went up to 100, and we can do that in 0.02 seconds. So if there are 100 continuous sum of nested integral, we can do that in relatively very minimal time. And another set of benchmark we use is product of nested integral. For doing that, our tool took 0.6 seconds of when we reach 100. So in conclusion, the delta decision procedure provide a promising way to solve formulas with integral, and we were able to realize this by implementing the dReal tool, and we were able to solve many privacy and fairness problem. For us, the next step is to, as I said previously, like for triple integral case, our tool doesn't perform well enough, so we want to optimize for higher dimensional integral. We want to optimize that. Next thing, we want to support partial derivative, and also we like to build some domain specific tool, verification tool on top of dReal. Thank you.
Can you get set up? So we would have time for one question, but yeah, go for it quickly, please.
You mentioned quantifier alternation. So can you say, like, is that coming from dReal, or did you have to do something to support that? Is it decidable? Can you speak more about the for all exists?
So it is decidable, and basically we built on top of dReal, so that's what comes with dReal also.
Okay.
So, but we did for the integral part.
Cool, thanks.
Thank you.
Thank you again.